What is up, everybody? It's Mr. Rowan here, back with my first post-quarantine video. So, I hope you all are staying safe and isolated. We're going to talk about special right triangles today, and everything that you need to know about these, you've already learned from SOHCAHTOA and the Pythagorean theorem. But these are a few special cases that are going to be particularly useful in Algebra 2 and later in pre-calculus. So if you take a look at this first example, we have a right triangle with two 45-degree angles. Now, you may remember that when a triangle has two angles that are the same length, that means that the opposite sides are the same length. So let's say that A is equal to 1, that means that B would also be equal to 1 because they're the same length. And then to find C, all you would have to do is to use the Pythagorean theorem and calculate it. So we know a squared plus b squared equals c squared. So 1 squared plus another 1 squared equals c squared. And this is pretty easy to add up. So 1 plus 1 equals c squared. So c squared equals 2. And then, so we get c equals the square root of 2. Now, typically, when you guys solve these problems, you like to put in a decimal. We're just going to keep it as the radical because that is the more precise answer, and that's the form that you're going to see. So, we know that if we have a is 2, then b would also be 2. So let's just quickly run through those calculations. So we get 2 squared plus 2 squared, so 4 plus 4 equals. So 8 would be equal to c squared. Now we can write that as the square root of 8, and we will write that here. But you can also split that up and make it a more condensed, simplified radical. So let's separate it out into its two factors. So 2 and 4 are two factors of 8, and then 4 can be split into 2 and 2. So since we have two factors that are the same, we can take those out of the radical, and we get 2 times the square root of 2. Okay? Square root of 2. Now, you can try the rest of these, and what you'll find out is that you'll start getting a pattern. So we see 25 plus 25 equals c squared. So that would be 50. And the pattern that you're going to see is that whenever you split this up, you're going to get whatever a is times the square root of 2. So 50, if you split that up, you can turn it into 25 and 2. And then the 25s get split up into 5s. Okay. And then you get 5 times the square root of 2. Okay. That's going to hold true for pretty much any time that you have a 45-45 triangle. It's always going to be that the two legs are the same length, and then the hypotenuse is the leg times the square root of 2. So let's look at a 30, 60, 90 triangle. So one of the things that we have to realize about that is that a 30, 60, 90 triangle is an equilateral triangle that is split in half. So you're always going to have one side is going to be half of the hypotenuse. All right, so let's say that we have, so A would be the shorter side. The shorter side is the one is BC. That's the one that's opposite the 30-degree angle. So if we calculate that, we get B equals the square root of 3. Okay, so let's do another example. Now you'll see in the first two columns, they're all nicely filled out for you, where we have one is going to be twice the other. The hypotenuse is going to be twice the shorter leg. So we get 25. All right, so we do a little bit of algebra, and you get b squared equals 75. So we can split this up the same way that we did with the other ones. So the square root of 75, so we'll split it into its factors. So 75, some factors would be 25 and 3. So 3, 25. And we know that 25 is a perfect square, so those factors can be split up into 5 and 5, just like we did in the previous one. So 25 goes into 5 and 5. And what it comes out to is 5 times the square root of 3. So you should be starting to see a pattern here too. What's going to happen is that all of these are going to be that the longer leg is the shorter leg times the square root of 3. So we have this handy graphic right here. For a 45, 45, 90, we're going to be taking the leg, we multiply by 2, and you can see that for the 30, 60, 90 triangle, these are the steps that you have to take. So I think this is mostly all you need to know about this. This is just a handy shortcut to have when you happen to have triangles that are exactly 30, 60, 90 or exactly 45, 45, 90. Then you can kind of skip all of the SOHCAHTOA stuff, and this should make those particular types of problems a little easier. All right, take care, guys. See you later.